sketch a graph of g of x equals negative 1/2 times x minus 3 quantity squared. Again, we're going to start with f of x equals x squared, and we're going to see how we can transform this function into the function that we need. Now, the very first thing we can do is we can replace x with x minus 3 and turn this into x minus 3 squared. So replace x with x minus 3. A w and a slash is a way that we can abbreviate the word with just to save a little bit of energy. This is fairly common. So we're going to do that, and we know that that ends up giving us a shift to the right 3 units. So shift right by 3. Now we've got the inside of the function to be what we need. We just have some things on the outside that are going on. So the next thing we can do is we can multiply this by 1/2. So that's going to be 1/2 times x minus 3 squared. And what we've done here is we've replaced our function, which was x minus 3 quantity squared. We've replaced this with 1/2 times the function. Now, when we take a function and multiply it on the outside by 1/2, that is a vertical shrink by a factor of 1/2. So shrink vertically by 1/2. And then we've got one more thing that we need to do. We need to take this function that we have and stick a negative out front. We need to take the opposite of that. So negative 1/2 times x minus 3 squared. What we've done now is we've replaced our function from the last step with the opposite of the function. And we know that when we put a negative sign outside of the function, that ends up being a vertical reflection about the x-axis. So we need to reflect about the x-axis. So these are the 3 different transformations that the original graph needs to undergo to turn into the new one. So let's do these one at a time. First, we need to shift everything right by 3 units. And this is exactly the same as how we did it in the last problem. Each point moves 3 units to the right. I'm going to do this quickly because we've already done this in the previous problem. All right. Now, after that, the next thing that happens is we need to shrink everything vertically by a factor of 1/2. So each of these points is going to move so that it's only half as far from the x-axis than it started. So this point is 2 units away from the x-axis. When we shrink that by 1/2, it ends up being just 2 units away. We go from 4 units to 2 units. This one is 1 unit away from the x-axis. Half of that is 1/2, so it gets even closer. And we've got this point all the way up here that's 9 units away. When we shrink that by half, it ends up being at a height of 4.5. Now, the vertex here is going to stay where it is, because when we're stretching and shrinking vertically, anything that's on the x-axis stays there. And then these 3 points are also going to have to be shrunk by a factor of 1/2 vertically. So this point goes here, the next one goes there, and then the one that's on the y-axis is going to go here. And so this is what happens to the points after the second transformation, when we shrink them vertically by a factor of 1/2. Now we've got a third transformation we need to reflect all of these vertically across the x-axis. So this point here is 4.5 units above the x-axis. We're going to move it 4.5 units below the x-axis. So it's going to go right here. This point is 2 units above, so we reflect it so that it's 2 units below. This point is just half a unit above, so we reflect it to half a unit below. The point that's on the x-axis will stay where it is, and then the other points get reflected below as well. We've got one that's half a unit below, one that's 2 units below, and one that's 4.5 units below. And now we finally have the points for our final function, our final transformed function, so we can connect the dots with a beautiful parabola, and this represents the graph of g of x equals -1/2 times the quantity x minus 3 squared. Things are a little bit more complicated when we have 3 different transformations that we have to do, but if we keep track of what happens to each of the individual points, we should be able to figure out what the transformed graph looks like.